First, you go to aws.amazon.com and you click create new AWS account. You enter your email address, a strong password. Enter a strong password, and then you just give it an account name. The account name isn't really important right now. You can also change it later. It's just something to identify your AWS account. The next thing is you have to enter details. I'm going to use a personal AWS account. You can use a company AWS account, a professional one. Enter your country and region where you live in, and so on. This is going to be the billing information, the contact information for you. Then you have to click the agree to the terms and conditions. You have to enter a credit card number. AWS will deduct about $1 or euro, depending on the currency you're in, from your account, from your credit card account, and then just see if this works and then refund you this. And it takes about 3 to 5 days. All right, last, you have to confirm your identity. This is where you need a working mobile phone. So you enter your phone number, and then you wait either for a text message or a voice call to arrive. And I'm just showing you how this works. I get my 4-digit verification code. Right, you verify the code, and then you hopefully get this check. And then you use the basic plan, which is free. And you are ready to sign into the console. You have to use your credentials that you just created. You use a root user because this is the root user that you create, and you're going to create an IAM user later in the course. One thing that you should early on select is the right region you're in. You can find the regions here on the top right corner. Amazon is divided into a couple of regions, so select the one that you are close to. Next to it, you find the account preferences, and I hope this was helpful. I will see you in the next lecture. All right, let's get started with our first lab where we're going to create an instance. We're going to log in, and then we are going to terminate that instance again. Now, before we are getting started, I want you to go to this top right drop down and select a region near you, which I'm going to do also for this whole course. I'm going to work in EU Central 1 because I'm located in Austria, and Frankfurt is the nearest to me. And the reason is it all behaves a little bit more responsive if you are in a region near you because of the, well, proximity of the physical proximity of the data center next to you. So I will not go and take one of the data centers in Asia because they are far away. I will take one in Europe right now. So if you are in Asia, you're going to select one in Asia. If I have a student from Hong Kong, I would advise him to take the Hong Kong data center. If you are in America, then take the one which is near you. Okay, now I have selected the right region. So I have a data center where I want to place an EC2 instance in. And now we can go to a service which is called EC2, Elastic Compute Cloud, EC2. And this will open an EC2 dashboard. And you can already see I have a couple of things here. And the first thing that we are going to do is not launch an instance on the spot. We are going to create a key pair because we want to log into this instance later on, and we need a key pair for this in order to use SSH to log in. So under networking and security, you find key pairs. And over here, I want you to create a key pair. You give this key pair a name, my AWS key pair, for example. And then I want you to select PAM if you use OpenSSH and you want to follow along in this course. Or if you use PuTTY already and you know what is PuTTY, then you can also use a PPK format. It's just a different format for a key pair. I will use PAM because I use SSH to log in. So then you hit create key pair. And what you will see is that AWS will automatically start a download of this file. So it's not going to store this file somewhere for download. It will directly let the browser download this file and redirect back to this overview. You can see I have already 4 key pairs here, and this is my newest one. So I don't do anything with this. But with the file itself, you should take it and copy it to an empty folder. So I'm going to do this now. I'm going to show in folder and then copy it to an empty folder. Okay. All right, you can see here I'm on Windows and I have copied my file to an empty folder now. And you have to keep this file secure because it is an unencrypted private key file giving you access to AWS resources you decide this key will have access to. All right, then you go back to the EC2 dashboard and you hit Launch Instance. Now we select an operating system that will run on our instance. And for this one, you will go with free tier eligible and you want to choose the Amazon Linux 2 AMI. It's called Amazon Machine Image. And what it does really is take a pre-configured OS and it's going to place it on some hardware. And the hardware that you are going to choose is here in the next step. And we are going to choose a type called T2 Micro. And it's giving us 1 vCPU. I will tell you later what it is exactly. 1 GB of RAM and some storage which we are going to configure in the next step. So you hit Next, Configure Instance Details. Then you have a lot of options here. You have networking options. You can have IAM roles attached to your instance, some shutdown behavior, some file systems you can attach, some advanced details, and so on. What I want to do really is just make sure that you auto-assign a public IP, which is enabled by default because you get a default virtual private cloud network. And I want you to select Terminate on Shutdown. All right, then you hit Next, Add Storage. So it's going to give you a root volume. You can also choose if this volume should be encrypted or not. I will choose it not to be encrypted. And I'm going to delete this volume on termination. So it's what is called ephemeral. What we're going to place on our instance. As soon as the instance is terminated, it's gone. Then we can add some tags. I will not add some tags. Then we add a security group. And the security group is like a software firewall around your instance, which says you can let the type SSH, which is port 22, from any IP address connect to your instance. So it's also giving you a warning, but we can safely ignore that warning for now because we are going to terminate the instance in a second later. Then we hit Review and Launch. So we see an overview of our instance that we want to launch. And then we hit Launch. And as soon as we hit Launch, there is a pop-up and says, well, choose an existing key pair that you want to place on the AWS instance in order to connect to it. So I'm going to choose my new key that I just created. And I say I acknowledge that I have access to the selected private key file and that I won't be able to connect to my instance without having this key pair. Then I hit Launch Instance. And then I hit View Instances. Now you see the instance will come up and it gets an instance ID and initial state pending. It is also placed in what is called an availability zone. So in EU Central 1, we have 3 availability zones, EU Central 1A, EU Central 1B, and EU Central 1C, and that are distinct data centers in one region. It will also get a public IP address, which I can connect later on to this instance. So I'm going to pause the video now. And we'll come back as soon as the instance has status checks 2 of 2 OK. Takes about a minute or so. All right, it says now 2 of 2 checks are OK. These are these status checks. So system reachability check passed and instance reachability check passed. So the instance is, as far as I can say, OK to connect to. So in order to connect, we could take our public IP address or the public DNS and write ec-user to add this domain or this IP address with the key. But there is an easier way, that is hit the connect, select the instance over here that you want to connect to and hit the connect button. And it will give you instructions how you can connect to this instance. So for example, if you're using the standalone SSH client like we are going to use, if you are on on Linux or on Mac, then you have to chmod 400 your key pair that you downloaded. So basically you have to run this in the folder where your key pair is located at. And then you can connect to this address with this command, ssh -i, and then your key pair, and then ec2-user at the domain. There is also a session manager. If you install it on the machine and give the right IAM profile and IAM roles to the machine, then you can connect with a session manager. I'm not going to use this. And there is an EC2 Instance Connect, which is a browser-based SSH connection, and you can basically just connect to the instance from the browser. But I still want to use the standalone client because I think that's the most standard way of connecting. So if you've never used this, then you should give this a try and use this. So I'm going to copy this example command because I'm on Windows, no need to chmod. I'm going back to the folder where my key pair is located at, and I'm going to open a PowerShell in that folder. On Windows, I can do this with holding the Shift key, right click, and open PowerShell window here. If you are on Mac or on Linux, then just go open a terminal and go to the folder where your key is located at. And then I basically just paste the command, and it will say, are you going to really connect to this instance because this fingerprint of the instance is unknown to the host system? And I say yes, because I know that is the system I want to connect to, and I am on the instance. Well, that's it. I can do all the Linux commands that I want to do on the instance, but I'm basically on the AWS infrastructure on an instance that is running on AWS. So that's really all there is to do to create an instance and connect to an instance. And now we're going to terminate this instance again. There's two ways to do this. One is you select the instance and hit right click and then say instance state terminate. The other way is you could just type into the shell, into the connection shell that you have open here, sudo halt, because we decided when we shut down the instance, we want to terminate it. But I'm going to go with right click instance state terminate. And it gives me a warning because the volume is going to be deleted as well. So we are going to terminate the instance, shutting down. And that's it. There's nothing more to do. And I will see you in the next lecture. All right, I think now it's time to talk a little bit more about elasticity and what exactly is elastic computing. So what is EC2? EC2 is Amazon Elastic Compute Cloud. So Elastic Compute Cloud EC2. It is a scalable computing capacity, and it essentially removes anything you need to invest upfront and shifts your capital expenditure to operating expenditure. And it gives you the chance to develop and deploy applications faster. The thing is, an EC2 instance doesn't do this initially. But if you connect it with other services, then you can much easier deploy your applications in a much faster fashion. The EC2 instances are virtual computing environments. So they are known as instances, and they consist of a couple of things. That is AMIs, instant types, key pairs, storage, networking, firewalls, IP addresses, and so on and so forth. So when we are talking about an EC2 instance, then we are talking about moving a traditional physical server where we have hardware, we have some OS and software layer, and we have configuration for all of this, to something like building blocks, where we have an instant type, where we have a CPU or GPU or RAM requirements. So we say we want one CPU with 2 gigabytes of RAM, and then we have an operating system on top that is done via an Amazon machine image. It doesn't have to be an Amazon Linux. It can be just an image of an operating system. It can also be Ubuntu or Red Hat and so on. And then on top, Amazon puts a secure login, your key pair, your public key, into this Amazon machine index image. And then on top, you have temporary storage and persistent storage. And that is an EC2 instance. Now, let's talk about those things in a little bit more detail. First of all, I want to talk about the instant types. The instant types describe the hardware capabilities for the instance, and they are grouped into several families. For example, there's compute instances, instances for high memory or instances for graphic operations and so on. And there are a couple of limits for regular users. You are somewhat limited to, I think, 256 vCPUs at the beginning, and you can extend them to 1152 vCPUs per region. So you can have quite a lot of performance from out of the box. So as I said, they are grouped into instance types, instance families. And you see here there are general purpose instances, compute optimized instances, memory optimized instances, storage optimized instances, and accelerated computing instances. And in these instance families, there are a lot of variations for instances. So for example, we were working before with the T2 micro instance over here, and this gives you 1 vCPU and 1 GB of RAM. And then it goes on with T2 small, it gives you a little bit more, T2 medium even more, T2 large even more, X large even more, and so on and so forth. There's a very large overview on the Amazon AWS page what these instances are and how they work. So the question that I had, at least at the beginning, is what is a vCPU? What can I imagine as a vCPU? I can imagine what is 1 GB of RAM, because RAM is quite universal. It gives you some memory. But what is a vCPU? So it is not as easy as you might think. T2 instances, families that start with T2, a vCPU is one physical core. So if you get one vCPU, then the hypervisor will take care of assigning you one physical core on the machine that you're working on. So if they have like an octa-core system and you get one CPU, one of the cores is for you. On all non-T2 instances, a vCPU is a hyperthread of a physical core. So it's mainly a logical core. And at least in 2018, they had, amongst other processors probably, those processors for the T2 instances. So if you are looking into benchmarking those, you will quickly find that on T2 instances, if you come from on-premise solutions, that they will pretty much correspond to similar server environment, server cores, or server CPUs that you are using for your on-premise solutions. So if you take an 8 vCPU instance, then you will get pretty much the same performance as an octa-core CPU. If you are using non-T2 instances and you take an 8 vCPU instance, you will get less performance, but you usually get other benefits out of that. So it's not always clear what to choose. I usually work right now with T2 instances, so it's easy for me. But there are other instances, memory optimized instances. If you need them, then you have to keep this in mind. The range is from 0.5 vCPUs to 96 vCPUs per instance, and I think that's a pretty large range. So if you have very high CPU requirements, then you can, or AWS can accommodate this certainly. Then the next thing I want to talk about is purchase options, because that's how the price depends on as well. So you have these CPU requirements and memory requirements, and then you can purchase different kinds of instances. The one that we chose before is on-demand instances. There you pay by the second for the instance that you launch. So if you launch an instance of T2, then the T2 instance costs you something per second or per minute, and depending on how long you launch it, then you will pay something for it. But there are also cheaper instances, and there's a savings plan where you commit to a consistent amount of usage. There is a reserved instance. You also commit to a consistent instance configuration. There's scheduled instances. There is spot instances, dedicated hosts, where you actually pay for a physical host. There is a dedicated instance that is, for example, interesting if you have any software that has a license agreement where it says, we are licensing the software for you for 1 CPU, and per CPU you pay. So it wouldn't be easy to accommodate this with standard instances where you don't know what kind of hardware is running on. But if you have dedicated hosts or dedicated instances, then you can decide what hardware they're running on. And then there are capacity reservations. And I think the two most frequent used instances are on-demand instances and spot instances. And especially spot instances are interesting because spot instances are unused EC2 instances. So every time AWS launches a new group of servers, they have to keep them running. And if nobody's using them, it's wasted compute resources. Even though they're idling, they're still taking energy, they're still having to run, there's still people on the premises to take care of those and so on. So Amazon offers these unused EC2 instances for up to 90% off, and there's a bidding operation on that. It's kind of interesting. If you want to keep a lot of resources, then usually you'd go by some sort of mix between on-demand instances that are always there and spot instances. And why? The reason is spot instances can terminate if there is somebody else who bids a higher price on those instances. So the pricing really depends on the instance type. For example, a T2 micro costs less than a T2X large. The type of rental. So maybe you are lucky and you get a T2 large for the same price as a T2 micro because the large might be a spot instance and the T2 micro might be an on-demand instance. The type of operating system you're running on. Linux is usually cheaper than Windows. And additionally, the region of placement. So US East is usually cheaper than Frankfurt. So again, the strategy to keep the price on a sane limit is usually, for web developers especially, on-demand plus spot instances. Spot instances have a termination notice of 2 minutes. And if you're running with Docker containers, as we will do it in these lectures, then there won't be any problem if your instance is terminating. So you can safely assume that our whole architecture will be around spot instances that are available. So the next thing that I want to talk about is the Amazon machine image. When you launch an instance, then you must specify an AMI. So there is no way around that. You can launch multiple instances from a single AMI, so it has basically the same configuration, and you can launch multiple instances from different AMIs. So you can have one Amazon Linux and one Ubuntu and one Red Hat instance running. You can also create your own AMIs. So how that looks like is you are creating your instance, and then you take an EBS snapshot. EBS stands for Elastic Block Storage. You take a snapshot, and it will you can register this as an AMI, and then you can launch instances from that AMI. It's like taking an image from your running computer. Then there is user data, and the problem is that even though you can create your own AMIs, sometimes you need to configure an instance to your environment dynamically when it's starting. So the first idea that you usually get is, well, I create a custom AMI, but sometimes that's not enough and sometimes that's not even needed. And this is where user data comes in. You can generate or you can build a generic AMI and then use the user data to modify the configuration of certain files or of anything that is running on your instance at launch time. So this is exactly what I want to do in the next lab. I want to get familiar with the user data field to configure an instance upon launch. All right, now it's time to start one EC2 instance with our user data field populated. And how do you do that? First, you go to the EC2 dashboard, and then you hit Launch Instance. You select, well, again, an Amazon Linux 2 AMI. I'm going with this one. I'm going to select the T2 micro instance again, then hit Configure Instance Details. And over here on the bottom, under Advanced, in the Advanced section, you find the user data field. And here you can write any script that should be executed at the beginning of the instance launch or at the instance launch. So I've already prepared one script, and you can find it also in the resource download attached to the lecture. Let me just quickly walk you through the script. It is a bash script, and it updates the local package database, and then it installs this Amazon Linux Extras. That's a package manager for the Linux AMI. So it's going to install these packages. Then it installs the Apache server and a database server. Actually, a database server we don't need, but let's install it anyway. And it starts the Apache server, and then it's going to add a simple PHP script called PHP info to the document root of the Apache in /var/www/html. This is where Apache is looking for files, and it's going to write this PHP script into this PHP info file. And PHP info basically prints the information of the installed PHP version. Just in case you've never seen it, it is just a long page of all the packages and the modules and configuration that PHP has on this server. Then it's just a nice way to quickly generate a text or an HTML file. All right, and then we are doing the same again. We have our auto assign public IP, which is enabled, and we are going to terminate the instance on shutdown. And we're gonna add storage. Yeah, that's fine. Security group. This time we have to change the security group a little bit because we actually want to get access to the Apache. So right now we just have SSH access. We have to add another rule, and that gives us HTTP access from anywhere. And we click review and launch, and then launch, and then we select our key pair and start the instance. Hit view instances, and then we wait until the instance is up and running. All right, the instance is running. Status checks are still initializing, but the instance state is running for a while now. So I assume that the script ran in the background already. And the way I'm going to connect to the instance now is take the public DNS name. Just copy this one. You can also take the public IP address, but I'm going to copy this one and I'm going to paste it into a new tab. And you can see that the Apache test page is coming up. And if I go to my php info.php script, then you see that there is the PHP version installed and all the modules that PHP has installed on that instance. Now, what happens if I don't have my inbound rules for port 80 set up? Then you have here the security group. And this instance is currently part of Launch Wizard 8 security group. This is the name that we gave the security group. And if I click the security group, then you can see there are a couple of inbound rules. Number one is for IP4 address, any address from any subnet. Port 80 is allowed to connect to this instance. IPv6, any address, port 80, and SSH port 22. Any IP4 address. So if I'm going to remove this HTTP inbound rules and I go back to my instances and I try to connect to this instance, then it will actually not give me an error instantaneously. It will time out. So it will just run for a while and time out. So if you have this kind of problem where you see that it's running, and it cannot connect, but it also doesn't give you an error immediately, that's a strong sign to check the security groups, go to the inbound rules, and just make sure that your inbound rules are set up correctly. So I could add here HTTP again from anywhere and save the rule, and it works immediately. Okay, that's it for this lab, and I will see you in the next one. All right, welcome back from the lab. I hope it wasn't too complicated. Let me just quickly recap what we did in the lab. Well, first of all, we launched a new instance, and that shouldn't be a surprise anymore. But then we changed the instance settings because we used the user data field to configure the instance at the startup. And we used this script here, which you can also find in the resource download attached to the lab lecture, where you are entering this basically in the user data field. And what it does is it installs Apache, it installs PHP and MySQL or MariaDB on the server during launch. It also sets some permissions, which you can find here. It sets the right permissions for a user so that Apache can read and potentially also write to this directory. And then it creates a PHP file with this echo, and that's it. And then we went to the browser, and then we had a look if we can output this one, and you saw that the security group had actually quite an impact on this firewall setting. All right, that's it. And in the next lectures, I want to talk a little bit more about the user data.